So I've given you the graph of y equals the sine of x here, and I've written down the basic points, those key points that I asked you to memorize. Now we want to look at the graph of y equals the sine of negative x. That tells me that I'm going to put the negative sign on x. So instead of xy, we have negative xy. Why don't you graph that function? I wrote the key points below. I made all of the x values negative of the previous key points. And we saw we get this bit I have in green. But of course that graph continues, right? That wave continues to below 0, 0, above 0. We always have this wave above and below. And let me remind you, I don't want to see a graph that looks like this. It's clearly not a mountainous kind of graph. It's a wave. So what's happening here? Well, what happens when we have a negative on x? We know that we have a reflection across the y-axis. Let's do the same thing. Oh, I had a separate space for graphing it. I'm sorry, I graphed it in the same spot. Well, here, let's now graph y equals the negative sine of x. So this time, the negative sign belongs on y. Why don't you find those key points here and then graph this function? Notice we have the same points on our graph. We labeled our x and y axis. We put 1 and negative 1 on y. We put our 4 intervals on x and labeled them intervals of pi by 2. And now we have our same y-intercept. And then instead of going up, oh, hang on, let's put on all of our intercepts. Every second interval. But then instead of going up to positive 1 at pi by 2, we're going down to negative 1. Up here, down here. Arrows at the end of your graph because of course this continues. This is also a reflection, but when we have an opposite y, it's a reflection across the x-axis. Of course, if I look at the graph y equals the sine of negative x, I can see that it has the same points, is the same graph as y equals the negative sine of x. We can see by looking at the graphs that sine is an odd function.